Hello, my name is Aneeka Mondal, and this is my CSI Senior Capstone project video. So, for this capstone project, we basically have the freedom to do whatever we want, create whatever we want. So I knew I wanted to make something that represented me. And I am somebody who loves to dance. Music, dance, everything. And I grew up playing this little game called Just Dance. And I decided that I wanted to create my own version of this Just Dance game. The biggest issue I found with Just Dance is that whether you're on the Nintendo Switch or the Wii, you have to physically hold the controllers, and you always end up accidentally pressing the buttons and doing something you don't want to. Or they'll go flying out your hands. Even if you have the straps on, it's still pretty annoying to have to do that. To fix this issue, I decided to try to make a wearable controller so you can use hands-free gameplay and be able to dance freely without having to worry about holding on to any kind of controllers.
After some research, I decided to use the Seed Studio ESP32S3 microcontrollers due to their small size and Wi-Fi capabilities, along with an MPU6050 gyroscope accelerometer sensor to track the player's motion data. For the actual game, I decided to use the Godot game engine, which I've used for a similar rhythm-based game in the past, and I knew I could reuse some of the same features on this project. Here are some of my first sketches of the product and circuit design. When the components I ordered came in, I started to build my circuit, connecting the ESP32 chip with the gyro sensor. I then started to make a prototype of what I wanted the controller to look and feel like, with it being attached to the player's hand through a Velcro strap on their wrist and middle finger. Next, I worked on the 3D print of the body of the controller that would allow the protoboard to slide into place and have holes for the slide switch and the USB-C port. Lastly, I met with my friend Milo, who was helping me with the graphics of my video game to discuss design ideas and work on progressing on the actual game. After I had all my bases covered, it was time to start making everything actually work, starting with soldering all the components to the protoboard. The gyro sensor collects data based on the player's movement, as shown here. So I needed to figure out how to translate this incoming data into a scoring system in my game. This was probably the hardest part of my project, and what I worked on for the longest time, as I had to make sense of all the data being sent by the gyro sensor, write a program to accurately show how the player is moving, and then create a scoring system in my game based on that positional data. I ultimately decided to track all the range of outputs given by each direction in the X, Y, and Z axes of the gyroscope sensor. So no matter if the player is moving forward, backwards, left, right, or anything in between, the controller will always know. This is the output it gets as my hand moves forward, backwards, left, right, everything. This is the game working at first with wired connection. And this is the wireless connection working, sending the movement data parsed into integers for easier communication. And this is a little bit of what all the game screens look like with all the songs you can select from. And lastly, here are some pictures of the final product.
Overall, I think the project went pretty well. I'm still working on small improvements to make sure the player's movements can be accurately read by the game and that processing is going well. I'm also working on adding a second controller so both arms can have movement detected from it and interfacing that with the game. Thank you for watching.